Spam, and these are my team members. We have Clay Conroy and Aaron Bloss, our electrical engineers. They work mainly on the wiring and power management aspect of our project. We have Alexander Keithis, John Burton, and myself, the computer engineers. We worked on the research. We worked on the research, testing, debugging portion of it. And so this is our project. What we wanted to do was that the Windows 8 operating system, which recently came out, adds a lot of touchscreen functionality, but most computer devices right now don't have touchscreen at all. And to add touchscreen functionality to it, we have to either buy a large multi-touchscreen monitor or maybe a Wacom tablet, which isn't very intuitive. So one other solution suggested at last semester's senior design was maybe to take a tablet and then use remote desktop off of that. And keeping that in mind, our goals for this semester was to develop a tablet-sized device that outperforms remote desktop in terms of frame rate and response time, as these were the two biggest complaints about remote desktop currently. And that moves us on to how we did all of this. We researched different wireless technologies so that we could communicate with the PC. We looked at Wi-Fi and Bluetooth, among other things. In the end, we actually ended up choosing wireless USB, as it was one of the only wireless communication technologies that could support the bandwidth needed for this device, and that it wouldn't require a expensive network infrastructure to already be in place to use this device. And to build this, ideally we would have liked to have taken a tablet, installed wireless USB into it, and start testing that. However, there were a lot of difficulties with that, since we don't have access to the information on how to work with such proprietary hardware architecture, and manufacturers aren't really going to just give us their blueprints. So instead, we basically designed a tablet shell. The shell is very simple. It was just a LCD screen with a touchscreen on top of it, connected with batteries and an enclosure to hold it all together. To this tablet shell, we added our wireless USB hub and the USB to VGA converter so that our device could communicate with a PC. The end result is the device you see pictured above. And after some benchmark tests, which shows that our device can display 3 times the frames per second that a remote desktop application could use. And it is 2.5 times as responsive as well. The one additional bonus, because we use wireless USB as our communication medium, is that it directly supports USB peripherals to be plugged directly into the device. Overall, this project shows that wireless USB is a possible solution that tablet manufacturers could look into to fill this gap in the market, this problem that we don't have enough input or touchscreen input for computers. Or the other alternative is that we could develop this device as a standalone product, as just a wireless touchscreen monitor that could be used in the field as well. And that's it. Do you have any questions?
Resistive or capacitive touch?
Ideally, we would have liked to use capacitive touch, but due to funding, we couldn't exactly do that, but it is very easily switchable. Currently, it is resistive though.
Single touch then?
Yes.
Why the difference in capacitive touch versus resistive?
Resistive touch can only sense one finger or one touch point at a time, up to 2 depending, but it doesn't allow multi-touch features very well. Capacitive touch can sense up to, the ones we were looking at can sense up to 10 points of touch, so that you can actually type really quickly.
And you have to switch out at your boot.
Yes, we do.
What's the range?
Wireless USB is only 30 feet though.
Any more questions?
What's the resolution of the screen?
I believe it's 800 by 600. It's a replacement from it's the IEE laptop, a small netbook.
What's the cost of your solution?
Full total development cost was $270.
It's around $270, and that is using hardware that is retail.
is basically just